Hello, good morning. We are about to start. So, for today's topic, we will be talking about coordinate systems in R2 and R3 and multiple integrals in the Cartesian coordinate system. So, that includes double integrals and triple integrals. All right. So, if you have questions right now, you may key in your questions so that we can consider it for later's discussion. Okay. Okay, good morning again. Welcome to our third synchronous discussion for our Math 28 bridging program. So for today, we'll talk about coordinate systems in R2 and R3 and multiple integrals in the Cartesian coordinate system. As what we did last time, I invited the lecturers for sections 4.1 to 4.3 to discuss some of the problems and exercises we have in that section. Okay, so I think we're ready to start. So we start first with section 4.1, that is coordinate systems in R2 and R3. Uh, Dr. Palines is already here. So I think if you have questions concerning R2 and R
Yes,
coordinate
good morning.
systems in R2 and R3. So you may ask Dr. Palines. Dr. Palines, good morning. So transfer ko na yung floor sa'yo for
Good morning.
discussions on 4.1.
Okay, thank you. Sir Jonathan.
Yes po.
Sir Jonathan. Okay. Malinaw yung audio ko?
Yes, malinaw naman.
Okay, thank you. I-request ko yung students na pakipin ng video ko. Ano kasi ang gagawin ko, magsusulat na lang ako. Doon nag-ready na ako ng solution kasi ayan, then gagamitin ko tong video na na camera ng cellphone. Camera. Okay. Malinaw ba?
Sir Herbert, naka-side view.
Sorry.
Bumaliktad.
Oo nga pala, no?
Ayan.
So, dapat ganito, no? Tama?
Yan. Yes.
Okay. Hindi ko na-realize. Anyway. Sige, i-fix ko lang to. Tapos, mag-start na tayo. Well, ang concern ko kung ganito, baka maliit. Anyway, pakisabi na lang kung okay ba. Sorry. Ayan. Sige. So, let's start in Form 1.
Naka-side pa rin siya, Sir
Exercise
Herbert.
number 1. Ano, maliit?
Naka-side.
Sorry? Sir
Na lang po. Paki-rotate.
Sir Jonathan.
Paki-rotate po.
Medyo nawawala yung naputol. Ako may problem.
Sir Jonathan, naririnig mo ako?
Yes, rinig ka naman po, sir. Kaya lang yung yung screen mo, naka-side, hindi upright yung text mo.
Tad.
Ah,
Baligtad? O sige, sayusin ko ha.
ayan.
Okay, alam ko na kung bakit.
Okay.
Sige, sige. Tinatext. So in one, basically your goal is to convert this point, which is a Cartesian coordinates, 493 to point coordinates. So we plot this point in Cartesian plane. So the x coordinate is 4, the y coordinate -3. So we'll land on the fourth quadrant for -3. So basically, since what we want is to locate this point using polar coordinates, so you need r, which is the distance of this point from the origin, and an angle, which is either a positive angle, which is given by this theta, or a negative angle, which is given by theta sub star. So in that case, if you compute r, basically we'll use this formula. So you will have square root of x squared plus y squared. So you'll have square root of 4 squared plus -3 squared. So if you simplify this, you'll have square root of 16 plus 9, or square root of 25, or square root of 5. So r is 5. Or in other words, the distance of this point from origin is 5 units. Now for the angle, or theta, you'll see if we're going to use the arctangent function. Basically, we started from tangent function, but if you want to solve theta, you will have arctangent or the inverse tangent function. So theta sub star is arctangent of -3/4. Now it will give you, based on the function value of arctangent, it will give you a negative result, or a negative number. That is fine. Well, but if in the instruction it says you find the smallest positive angle, so you should find this theta here in counterclockwise direction. Ayon. So in that case, theta, so all you have to do is to add 2 pi to arctangent of -3/4. And now here, this will be the smallest positive angle, or the smallest positive value of theta. So in that case, the polar form, the polar form of the point for -3 is given by 5, or the polar coordinates corresponding to Cartesian coordinates for -3 is given by this, 5 and arctangent -3/4 plus 2 pi. So that's the first item, the exercise. Do you have any question before I proceed to the second item? Sir Jonathan, naririnig pa rin ako?
Yes po, clear naman.
Okay. Okay, thank you. Kung walang question, let me proceed to number 2. I think nag-practice ako kanina, less than 30 minutes naman tong 5 exercises. So,
Okay.
saka sinulat ko na rin para mabilis. Pakisundan na lang dahan-dahan, no? And now, in number 2, your goal is the other way around. You're given with a point in polar coordinates, given by 5, 2 pi over 3. Now we will convert these coordinates to Cartesian coordinates. So here, as you see, I plotted the point in polar plane, though my label, yeah, it's in polar plane. So just imagine this is polar plane. So this point is 5 units from the origin, and its angular measurement from the positive x-axis is 2 pi over 3. So ito yun. So pi over 3, then 2 pi over 3. So basically, what we want is to get x coordinate of this point and the y coordinate of this point. But that's actually, that is quite straightforward mechanically, because if you know the conversion formulas for x, which is r cosine theta, and y, which is r sine theta, this is quite straightforward. So all you have to do is to replace r5 and theta by 2 pi over 3, and then compute 5 cosine 2 pi over 3. And this, know that cosine, sorry, I fix ko lang yung camera. Okay. And we know since cosine 2 pi over 3 is -1, so x will be -5 halves. So similarly, y will be r sine theta, or 5 sine of 2 over 3, or 5 times square root of 3 over 2, or 5 square root of 3 or 2. So in that case, the Cartesian coordinates is given by -5 over 2 and 5 square root of 3 over 2. So as you notice, mas mabilis kung from polar to Cartesian. Kung Cartesian to polar, you see in theta, pwedeng maraming values, no? Maraming posibleng values. So that's it. That's number 2. Do you have any questions? By the Sir Jonathan.
Yes po.
Paano pala yung mechanics sa question and answer? Later ba or?
Kung may tanong naman sila, nagtatanong naman sila agad. Actually, meron na ditong isang question, pero later na lang pagdating sa spherical coordinate system.
Okay, sige. So let me now proceed to the third item in exercise. So number 3, equations na to, guys, no? But basically, ganun pa rin. If you, yung conversion ng points to points, tapos equation to equation, essentially the same. All right? As long as you know the conversion formulas. So in this case, we are given with a Cartesian equation, or an equation in Cartesian form. And you can easily notice this is a line. No? This is equation of a straight line in 2D. We will convert this into polar form of this form, r equals f of theta. So as I have said, as long as you know the conversion formulas, no, from x to r and theta, and y to r and theta, so you can easily do this. So just replace x by r cosine theta and y by r sine theta. And since it is required that the form should be a function r as a function of theta, or r equals an expression in terms of theta, you just have to rewrite this now. You factor out r from these two expressions here, or these two terms, and then divide both sides by a cosine theta, b sine theta. Of course, there is an assumption that this expression here should not be 0, no? But most of the time we don't say it explicitly. No, implicit should be non-zero. Otherwise, it's undefined. And that's it. So in other words, this is the general form of a straight line in polar coordinates. Okay? So let me now proceed to the fourth item. So in number 4, we are given polar equation, and I guess you know the form of this equation. No, as you've seen in number 3, they will convert this into Cartesian form. So again, using the convert formulas, all we have to do, this is not quite straightforward. As you should see the given equation, a form something like r sine, correction, it should be cosine, r cosine theta and r sine theta. Before, you could replace that by x and y respectively. So in other words, all we have to do is to rewrite this first, no? By multiplying both sides by 2 sine theta plus cosine theta, you will have on the left hand side 2 times r sine theta plus r cosine theta. On the right hand side, you will have 1. And as you see, based on our conversion formulas, this will be y, r sine theta, and this will be x, r sine theta. So you will have 2 times y plus x equals 1. And clearly, in Cartesian form, this is straight line, no? The equation of a straight line. Since we need to sketch this, so we already identified the equation. It is straight line. We now sketch the equation. So what you can do is to get the y-intercept and x-intercept. So when x is 0, y is 1/2. No, you could easily see that here. When y is 0, x equals 1. So we just plug these 2 points. We'll have 0, 1/2, and 1, 0. And then draw a straight line through these 2 points. And that is the equation of this. Okay? And I guess, so kung wala pa ring question dito, let me now proceed to the last item. This item tackles cylindrical coordinates on R cube. So let me emphasize, guys, what we've discussed earlier are coordinate systems on R squared or on a plane. So now we'll proceed to R cube in 3-dimensional space. And we know we have 3 possible coordinate systems in Math 28. It is either Cartesian, cylindrical, or spherical coordinates. And we can convert from one coordinate form to another. And as you see in number 5, we are given with a point in cylindrical coordinates. No? So these are cylindrical coordinates. And we will convert these to Cartesian coordinates. So take note, cylindrical coordinates, practically speaking, is just a combination of polar coordinates and a cylindrical coordinate. So as you remember, or as you saw in the lecture videos, these 3 coordinates here correspond to r, or the distance of the point from the origin. Sorry, not the point per se, ano? I mean the polar point, no, na nasa polar plane or nandito sa horizontal plane, sa xy plane. Yan, distance niya yan dyan. This is theta, the angular distance from the positive x-axis on the xy plane, no? And z, the directed distance from the xy plane. Ayan, so r theta z. So therefore, actually, as you see, this is basically conversion of polar to Cartesian coordinates, no? So x and y. So using conversion formula, so x will be r sine theta, or 3 cosine pi over 6, or 3 times square root of 3 over 2. Yeah. And for y, you'll have r sine theta, or 3 sine pi over 6. So 3 times 1/2, or 3/2. And conveniently, as you see, you don't need to change the third coordinate because this is already a cylindrical coordinate. A Cartesian coordinate. The z coordinate, 5. So yon. Okay? So the Cartesian form of that cylindrical coordinates are given by this 3 square root of over 2. For x, for y is 3/2, and z is 5. So that's it. If you have questions, I guess the floor is now open for questions, if any.
Sir Herbert, ang question dito ay about spherical coordinate system. Kung pwede ka daw magbigay pa ng isang example.
Yes, anong
Kung pwede ka daw magbigay ng isa pang example sa pag-graph
example?
sa pag-graph ng spherical coordinate
pag-graph.
system. Yeah.
Okay, sige. Please take note, sa Math 28, we chose a specific references, no? Nakita online, iba't iba yung, pwede mag-iba-iba yung references na gagamitin pagdating sa spherical coordinates. So let me emphasize first in general. So how do we, let me label this, the usual orientation that we consider. The z-axis is the vertical axis perpendicular to the horizontal axis, which is usually the xy plane. Horizontal perpendicular to xy plane. So this is the usual orientation that we use. So kung meron kayong cylindrical coordinates, in that case, I think our variables rho for the distance of the point from the origin, and rho theta, right? And phi. Medyo tricky ito kasi hindi siya, how could I say, hindi siya parang step by step or one step at a time. Kaya medyo tricky ang ang spherical coordinate. So rho, as I have said, will be the reference point for measuring rho. It's the origin. So you will measure rho from the origin. And theta here will be measured from the positive x-axis. Pero hindi, I will explain this later. And here is measured from the positive z-axis. So look at these references, no? Mahalagan. Para alam natin kung paano i-plot or indicate ang point using spherical coordinates. So rho will be measured from the origin, theta from the positive x-axis, phi from the positive z-axis. Okay? So, for example, if we have this point in Archimedes using spherical coordinates, so rho is basically the directed distance of this point from the origin, or the absolute So rho is represented by this distance, so that is rho. So where is now theta? Now what you do is to project that sa xy plane or sa horizontal plane. After projecting, no, so you will get a point that corresponds a projected point, no, in the xy plane. So this will be a point on this plane, and then theta is actually the angle measured from the positive x-axis. That is theta. Okay, and then where is phi? So you will measure that angular distance from the positive z-axis. So medyo mahirap tong ma-imagine kasi nasa t ito, Pero if you could imagine a plane, mabilis ma-imagine yan if you could see it as a plane. Yan. So ito ay isang plane, ano? So on that plane, you measure phi. Yan, so that is phi. So for example, siguro lagi ko magbigay na lang ako ng particular values sa rho, theta, and phi, ano? Hindi na gumamit ng another visual. So rho, say as you see, if we could, let me just set a rho is say 5 and theta is around pi over 4 and phi is around, let me say pi over 3. Ayan. So essentially, so 5, you will measure 5 units, no? By the way, yung units, guys, depende sa isa-set nyong unit. So let's say sa x-axis, ang unit ay ganito kalaki, ano? So that is 1 unit. So that means yung 5 units will be 5 times of this. So 1, 2, 3, 4, 5. Assuming ano na 5 units yan na sinetin dito. So that's 5 units. Wala namang problem dito sa angle. Madali nyo ma-estimate. So say this is pi over 4. Okay, so let me start from 5. Now we will measure 5 units from the origin. So okay. Mukhang hindi pala yon ang, I just realized, hindi yon yung mas systematic na procedure. Ano? What you can do, no? Kasi yung kanina, nag-start ako from the point eh. Ngayon kasi pabalik tayo, no? Hindi natin alam kung saan to, kung nasan ito sa space. Ang given lang sa atin ay coordinates. So, iibahin natin yung approach. So, this is my proposal. Here's one option. How would you do it systematically? So what you can do is to locate theta. Unahin natin to. No? Sa xy plane. So you locate that. So bawa, nalaman nyo, this is pi over 4. And then you just draw this line here. And now this is the most tricky part. You will combine now the information when by rho, which is 5 units, and phi, which is pi over 3. So it's a combination of these two, no? So what you can do now, I guess, no, is to have pi over 3 or measure pi over 3 units. So isunod natin yung, so this is the first, sunod natin tong phi, the second. So how we do that? So we'll measure from the z-axis pi over 3 units. So kung na-imagine nyo, ano, yan, pi over 3 units. So therefore, that point could be anywhere, somewhere dito sa na to. You could imagine, ano? Ayan, nandyan yan. Paikot. Pero, kailangan natin siyang itapat dito sa line na to, determined by theta equals pi over 4. So therefore, mapipredict nyo na kung nasa na yung exact location. So dapat itapat nyo dito. Then imagine this line, no, na nakatapat dyan. And then you count 5 units. 1, 2, 3, 4. And that will be the exact location of that point given by these coordinates. Okay. Did I clarify the concern?
Actually, ang concern dito ay with respect to the graph. Siguro ano na lang mas magandang
With
strategy.
respect to the graph.
To the graph. Siguro ano na lang mas magandang strategy. Suppose I have a spherical equation.
Magka-graph?
Oo.
Okay. You mean given the equation kung ano yung graph ng spherical, ano yung graph ng equation in spherical coordinates?
Yeah.
Okay. Actually, limited yung
Or
example.
siguro ano na
dito
lang,
eh.
strategy. Oo nga eh. Siguro strategy na lang.
Okay. Paano ba? Ang
Kasi
naisip
nakikita
ko lang
ko dito,
maging familiar si dun sa
sige.
sa common example. Kasi kung spherical coordinates, commonly, ang graph na kino-consider natin or yung pinaka-convenient gamitan niya ay malapit sa sphere. So variation ng
Yeah.
spheres yung magiging examples. So tingin ko yung isa, number 1 strategy is to be familiarized with the examples. Number 2, kung hindi familiar yung example, actually wala pa akong maisip na strategy. Baka mayroon kang suggestion, Sir Atan?
Actually, ang naiisip ko lang na strategy, aside from familiarization, is you have to always convert it to Cartesian equation. So if you have a spherical equation,
Actually, yes, oo.
you convert it to Cartesian equation. Then from the Cartesian equation, you write it in standard form para nakikita mo kung anong klaseng quadric surface siya. Basically, kapag nasa spherical equation ka, these are just non-degenerate quadric surfaces. Tama ko, no, Sir Herbert?
Yes. Actually, yun na ata ang isang pwedeng gawin. Or I mean,
Yeah.
yun lang ang tool na pwede nating gawin sa Math 28. Tingnan mo as in cylindrical coordinates. For example, yung commonly ang kasi kaya nga siya spherical coordinates. Halimbawa yung example na rho equals, let me say 3. R cube, we know on R cube this is a sphere. Given that you are using spherical coordinates, we will all agree that this is a sphere on R cube. Yung sabi ni Sir Jonathan, how would you verify that? You convert this using the conversion formulas. So we know rho squared is simply x squared plus y squared plus z squared. So as this is the relation between rho in the spherical coordinate and xyz in the Cartesian coordinates. So if you replace this rho, so rho is actually x squared plus y squared plus z squared. So as you see, if you replace the rho, you will have x squared plus y squared plus z squared equals 3. So this is a sphere. Center niya ay origin. Ang radius niya ay square root of 3.
Herbert,
I
nalito ka
guess
na.
mukhang lang yung tool natin sa Math 28.
Sir Herbert, nalito ka na sa sinulat mo.
Okay.
Sir Herbert.
Ha?
Nalito ka na ata sa
yes.
naisulat mo.
Tama. Sorry, correction. This should be walang square root,
Yeah.
Mali ako. Nalito nga ako. Thank you, Sir Jonathan, for the correction. Baligtad. Ito dapat yung may square root.
May square root.
Dapat pala, di ko na nilagyan. Ito yung wala.
Yes.
Tama, no?
Yes.
Yan, baligtad.
Tapos sa third line mo,
thank you.
Yung sa third line, that should be
ito pala
9.
ay rho squared.
Yep. Yan.
Ayan. So therefore, we'll have So dapat ito pala.
Yes.
No,
Yes.
kasi ang radius niya ay 3.
Yes.
Tama. So consistent na siya dito. So
Yes.
this is a sphere of radius 3.
Yep.
Yan. So ito, radius niya ay 3. So mali ito. Okay. Yan yung common example. Kasi ito yung pinaka clear illustration why the coordinate system is called the spherical coordinates. No? Convenient siya for this kind of
Yes.
equation.
Yes.
Yung malapit sa sphere. Yun lang yung may bibigay kong example regarding this or illustration. Okay na ba tayo sa 4.1?
Yes, I think.
Okay.
Bakit yun?
Sir Eton, mag-exit muna ako ha.
Saan na?
Okay. Thank you, Sir Palines.
Paano?
Okay. Thank you. Thank you for your time.
Tatay.
Bye.
Hindi ko alam.
Bye.
Hindi mo na kay tatay.
Ang kulit na ng baby mo. Okay, so meron kayong iba pang clarification concerning this? Concerning coordinate systems? Okay, so kung wala, I think we can now proceed to multiple integrals in the Cartesian coordinate system. Okay, so we start first with double integrals in Cartesian coordinate system. So I have invited Sir RD. Morning, Sir RD.
Hello, sir. Ako na ba?
Yes.
Sorry, na-disconnect. May Cocomelon team kasi dito sa bahay.
Ay, ganun.
Anyway, sir, pwede ako mag-share screen?
Go.
Okay po. Ay, wait lang pa. Ayan. Okay na po. Kita na po yung slide.
Yan, kita na.
Ayan. So, hello. Good morning, everyone. I can see familiar faces dito sa sa room na to. Hello. Kaway-kaway sa 28Y3R and X3R. And ayun, off ko na lang yung video ko kasi yun nga, may Cocomelon team dito. Pang-agos sa bandwidth. Anyway, so audible po ba ako?
Yes.
Okay po, sige. Ayan, so for today, I was tasked to discuss some of the items on your exercise, in particular with double integrals in Cartesian coordinates. Ayan. So before we proceed, let's have a recall. On the lecture video, recall that an iterative integral is of the form denoted by this, ayan, double integral, where dA is equal to, can be set into dx dy or dy dx. And also I've mentioned on the lecture video that use dx dy kapag gagamitin mo horizontal strips on approximating the region bounded by R, tapos dy dx kapag vertical strips naman. And then, whenever you are setting up double integral in Cartesian coordinate, please take note that dapat ang goal nyo, makahanap kayo of makagoal kayo na makahanap ng function z, which is a function in terms of x and y, and it is bounded by a region R on the xy plane. Ang role nito is si z will be your integrand doon sa double integral. Tapos itong si R will help you determine the bounds of integration. Ayan. Okay? So let's proceed with the exercise items. So start tayo with item number 1. So we need to find the volume of the solid that lies below the surface given by z equal to 16xy plus 200 and lies above the region in the xy plane bounded by y equals x squared and y equals 8 minus x squared. Ayan. So first thing to do is determine nyo muna ano ba yung function z net in terms of x and y at saka ano ba yung itsura ng region R para ma-set up natin yung iterative integral ng madali. So, hanapin muna natin, what is the function z? Well, of course, given sa atin is ito, yung z equal to 16xy plus 200. So, that is, siya yung magiging integrand natin. Okay? Now, it is also given that meron tayong region in the xy plane bounded by these two functions or equations. So a region R natin is the xy in the xy plane is bounded by these two equations. Y equals x squared and y equals 8 minus x squared. Okay? So meron na tayong integrand. Ang problema na lang natin is ano ba yung magiging bounds of integration natin. So for us to get the bounds of the integration, we further investigate itong region enclosed by these two equations. So here, given the graph of y equals x squared and y equals 8 minus x squared, so ito yung graph na ito. Ayan. And then we find the intersection points. So we have intersection points at negative 2, 4, and 2, 4. So, yan. Now, tingnan natin. If we use, saan yung pen? Ayan. So if we use horizontal strips para ma-approximate ito yung area, ano mapapansin natin? If we move downward, yung area natin is bounded by x squared, tama? Pero upon passing through this, yan, line, sorry, hindi straight. Ayan. If you move upward, magbabago na yung ating bounds. So, meaning to say, kapag nagbago ng or there is inconsistent doon sa bound natin sa region, that implies na magkakaroon tayo ng at least 2 integral according of the iterative integral. Ayan. Pero in this particular example, ayaw pa na mag-back. Sorry. Ayan. Gamitin natin ang vertical strips. So if we use vertical strips, ano nga yung ano na natin? Variable order of integration natin, dy dx. Tama? Okay. Now for the inner bounds ng ating iterative integral, okay, we consider the upper bound or the upper curve at saka yung lower curve dito region na to. Tama? Okay. And then, since dy dx, make sure that yung inner bounds natin will be expressed in terms of x. So for our upper curve, given siya by 8 minus x squared. Tapos for our lower curve, consistent naman na x squared. So hence, your bounds for the inner integral is from x squared to 8 minus x squared. Okay. Now, for the bounds of the outer integral, ayan, we just determine the range of values at which magta-travel itong vertical strip natin. So if you move to the left, sagad na tayo at x equal to negative 2. But if you move to the right, we'll end up with x equal to 2. Hence, the bounds for the outer integral will be from negative 2 to 2. So hence, the volume is given by this iterative integral. Ayan. Pero ang sabi sa atin, we need to find the volume. So hence, we have to evaluate this integral. Tama? Okay. So, first, integrate natin si 16xy plus 200 in terms of with respect to the variable y. So from here, 16xy will become 16xy squared over 2, or simply 8, 8xy squared. Tama? And then si 200 dito, upon integrating with respect to the variable y, magiging 200y. And then we evaluate it to the bounds x squared to 8 minus x squared. And then, upon plugging in itong bounds natin, yan, the integral will become this. So we have an integral of from negative 2 to 2 of negative 128x cubed minus 400x squared plus 512x plus 1600 dx. Okay, and then we then integrate this with respect naman to the variable x. So we have this, and integrate to from negative 2 to 2. And then upon plugging in these values and upon simplification, we get the volume equal to 12,800 over 3. Ayan. So that is for item number 1. Questions so far? Hello? May question ba for this item?
Mukhang wala, sir.
Mukhang wala
Sasagot.
naman.
Mukhang wala.
May kausap ba ako dito? Joke. Anyway, ayan. So if there is no question, or if there are no questions regarding with this item, let's proceed with item number 2. So for item number 2, find the volume of the solid enclosed by the planes. For x plus 2y plus z equals 10, y equals 3x, z equals 0, x equal to 0. Ayun. So again, first thing that we must do is to find a function z in terms of x, y, and analyze the region R on the xy plane. So saan natin kukunin si function z in terms of x, in terms of variable x and y? Kunin natin siya dito. Ayan, hindi pa ano. Tama? So if we isolate z here, ano mangyayari? Sige, admit na. Ayan, so for our given, we have a function z in terms of f of xy equal to 10 minus 4x minus 2y. Now, for the region R, in the xy plane, take note that meron pa tayong tatlong conditions dito, tama? So gamitin natin sila. Okay, so dapat yung region R natin is bounded by, unahin muna natin kay z equal to 0. Ayan. So if z equal to 0, ano mangyayari sa z dito? Magiging 0 to, tama? And hence, we can have a line x plus 2y equals 10. So tingnan natin kung tingnan natin yung case at which yung z equal to 0 at ito yung makukuha nating line on the xy plane. Okay? At the same time, bounded rin daw si R by y equal 3x, y equal 3x. And lastly, bounded rin siya by x equal to 0. Okay? Now we further investigate the region bounded by these three. So ito yung graph on the region R. So we have 4x plus 2y equals 10 ito. Y equal 3x given by this, tapos x equal to 0 by this line, or simply the y-axis itself. Ayan. And determine the intersection points, or ayan, the corner points para sa para sa bounds ng outer integral. Ayan, yun yung sense niya. Okay, if you use horizontal strip, so dx dy, take note, may inconsistency dito sa rightmost curves, tama? Okay, so therefore, magiging dalawang integral siya. But if you use vertical strip, that means order of integration is dy dx, then consistent naman yung upper at saka lower curve. So it will imply that meron lang tayong single integral for this if we use vertical strips. Okay, so in this particular example, isa-set up lang natin yung integral and the evaluation at pagkuha ng volume will be left as an exercise. Okay? So set up natin. Take note, yung z natin kanina is given by this 10 minus 4x minus 2y. So hence, that will be your integrand doon sa ating iterative integral. And then, for the bounds of the inner integral, ano nga yun? Kunin lang natin yung curve. Since dy dx tayo, we need to express the curve, the upper curve at saka the lower curve with in terms of the variable x. So ito, wala nang problema kasi yung lower curve natin is 3x. Ito, we have to convert this into y equal to, by isolating y, ano makukuha natin? 5 minus 2x. Tama? Ayan. So from here, for the inner integral, ang upper bound natin will be 5 minus 2x and ang lower bound natin is 3x. Okay? And then for the outer integral, take note, if you move, ayan, lagay natin yan. If you move ito strip natin going to the left, sagad na tayo at x equal to 0. And then if you move to the right, we have at x equal to 1. So hence, ang upper bound is 1, ang lower bound is 0. So hence, we have the following iterative integral for the volume. Ayan. Question for this item?
Sir RT, may question from YouTube, pero from item 1.
Okay pa.
Ano daw magiging bounds if horizontal strips ang ginamit?
Sige pa. Balikan natin, sir. Ayan. So, kung horizontal strips na gagamitin, edi ano tayo? Sige, set up na rin natin. Dx, dy. Ang pangit ng sulat. Anyway, ayan. Pero sabi ko nga, ayan, pwedeng dalawa yung dalawa yung magiging integral natin. So, dx, dy. Tapos pareho silang 16xy. Bakit ang sulat ko? Sorry. Plus 200. Dapat pala nag-mouse ako. Tapos ito, 16xy plus 200. Ayan. Pagpasensya niyo yung sulat ko, wala akong mouse. Ayan. Anyway, consider muna natin itong region dito sa baba. Ayan. Take note, ito is given by y equals x squared, tama? Okay. So, ang kailangan natin for the bounds of the inner integral should be expressed in terms of the variable y. So, from here, by isolating x, we have x equal to positive, negative, square root of y. Tama? Okay. So, clearly, ito yung magbibigay ng ng positive square root of y, itong part na to. Tapos itong part na to is negative square root of y. So from here, we have negative square root of y to positive square root of y. Okay? Now, if we move itong strip natin downward, sagad na tayo at y equal to 0. And then, take note, yung bounds na to is only applicable at up to this line where y equals 4. So we have from 0 to 4. Ayan. Next, investigate naman natin itong upper part na to. Ayan. And then take note, your rightmost curve is given by, and leftmost curve is given by this. So express lang natin to in terms of y. we have x equal to positive, negative square root of 8 minus y. Ayan. Wherein, itong part na to is the positive square root of 8 minus y. Tapos itong part na to is the negative square root of 8 minus y. So, we have from negative square root ng 8 minus y. Tapos ito, square root of 8 minus y. Okay? Now, in this particular region, if we move this horizontal strip downward, mag-start tayo with y equal to 4. And then if you move upward, we'll end at y equal to 8. Ayan. Sorry sa sulat ko. Pero did I address the question?
Yes, Sir RD, na-address naman siya.
Okay po. Pagpasensya na yung sulat ko. Sa PowerPoint kasi. Tsaka wala akong ano. Ano po? Question so far with item 1 and 2?
Wala naman na sa YouTube.
Okay pa. So sa item 2, yung setting up at saka evaluation in terms of dx dy will be left as an exercise. Ayan. And then in this particular presentation, hindi ko na in-include si items 3 and 4 kasi sila ay pattern lang din doon sa previous items. So skip tayo with item number 5. Okay. So use a double integral to determine the volume of the region formed by the intersection of the two cylinders, x squared plus y squared equal to 4, and x squared plus z squared equal to 4. Okay. So given, ano yung function z natin at ano yung region R? Kasi ang given lang sa atin dito ay dalawang cylinder. Tama? Okay. Pero for the function z, since itong equation na to, ang may variable na z, so more likely, dito natin kukunin yung integrand. Okay? However, we need to investigate kung ano ba yung itsura ng solid on the intersection of these two. So, graph muna natin siya. Okay. So, ito isa, cylinder with radius equal to 2, the xy plane. Tapos extend lang siya with the z-axis. Itong isa, cylinder with radius 2 din, pero extension niya, cylinder tuloy. Circle siya on the xc plane with radius 2, centered at 0, tapos extend siya sa y-axis para maging cylinder. So, intersection siya niyan. Ayan. Itong isa, lagyan natin ng marker. Ito yung, sige, mark natin ito as 1. Ito yung 2. Okay. So yung graph nitong 1 sa 3D coordinates ay ito. Tapos ito yung sa 2. Okay. Now, anong itsura ng intersection niya? So ito, pa-circular siya pag ganun. Ganyan. Tapos at the same time, ito, hindi ko sure, hindi ko rin siya ma-visualize. Pero parang ano siya, sphere at some sense. Ayun. Kasi circle siya dito, tapos pagdating dito, ayun, mag-iano siya dito. Ayun. Anyway, so, determine natin yung given. So sabi ko nga, from before, si function z, in terms of x and y, pwede natin siyang kunin dito sa x squared plus z squared equals to 4. So upon isolating z, we can get z equal to positive, negative square root of 4 minus x squared. But take note, nasan ba yan? Ayan, di ba? Ayan. Take note, itong part na to, sige, analyze natin. Di ba ito yung graph doon? Take note, yung part na to is symmetrical dito sa part na to. Tama? Okay. And then itong part na to is given by the positive square root of 4 minus x squared. Ito, tapos itong kabila ay yung negative. But since symmetric naman siya, if we consider itong positive square root of 4 minus x squared, para ma-capture natin yung region or yung solid given the negative, we can just simply multiply our integral by by 2. Yan. Gets ba? So, ngayon, settle na tayo sa integrand natin and take note, i-multiply natin si integral by 2 para ma-capture yon sa negative. Yung solid given ng negative square root of 4 minus x squared. Ang problema na lang natin here is how do we get the bounds of integration? So for the bounds of integration, analyze naman natin yung si equation 1. Yung itsura ng graph at x squared plus y squared equals to 4. Ayan. Ayaw matanggal. Sorry. So ito yung graph ng x squared plus y squared equal to 4. So circle siya centered at 0 with radius 2. Okay? And then, in this particular example, gamit tayo ng vertical strips. So meaning, gagamit tayo ng dy dx. Now, for the bounds of the inner integral, we have to express ito in terms of the variable x. So, from here, we can have y equal to, same lang din pala. So, positive, negative, square root of 4 minus x squared. Okay? Where yung positive 4 minus x squared ay ito. Tapos, yung negative 4 square root of 4, yung negative square root of 4 minus x squared is given by this lower semicircle. Ayan. So hence the bounds for the inner integral is from negative square root of 4 minus x squared to positive square root of 4 minus x squared. Okay. Now, if you move to the right, for the outer integral, I mean, we have to investigate kung ano ba yung bounds ng vertical strip natin if you move to the left at saka to the right. Going to the left, sagad na tayo with x equal to negative 2. And going to right, we have at x equal to 2. So hence, the bounds for integration for the outer integral is from negative 2 to 2. Ayan. So again, bakit ko nilagyan na times 2? Para ma-capture yung solid generated doon sa integral kapag consider natin yung negative square root of 4 minus x squared. Okay? Question for this item? Ayan. Question regarding this item po?
Mukhang wala naman silang question.
Wow. Sana all.
Naintindihan nila.
Ayun. Baka nahihiya lang kayo magtanong ngayon. Pero if you have questions that accidentally pop up on your mind, ayun, don't hesitate to chat me on Facebook, yan, or email me. Ayun. Re-respond naman ako. And if wala ng question, ayun, thank you for listening and I hope, ayun, marami kayong natutunan with this discussion.
Okay, thank you, Sir RD. So that's for double integrals in Cartesian coordinates. So ngayon, extend naman natin to triple integrals. So, transfer ko na kay Ma'am Sheena.
Hello, good morning. Rinig po ba ako?
Yes po.
Hi, sir. Kaya po ba nila? Baka kaya hindi nagtatanong. No?
Kaya pa yan.
Mag-share screen ako. Nasaan na yun? This one. Okay, kita po ba? Yan, so good morning everyone. So for section 4.3, so gawin naman natin yung triple integrals, no? So kagaya sa discussion ni Sir RD, magkahawig lang halos, no? naging tatlo lang yung integrals dito. Okay, so we have this triple integral. Ito sa first exercise natin, so you are given this triple integral, you have to evaluate it given given the region as described. Okay, so yung first step natin dito as discussed sa video is you have to write this in iterative integral. Okay, lalagyan lang natin ng bounds yung triple integral dito. Okay, so, sulat lang natin yung triple integral. Madulas masyado yung aking. Let's write yung triple integral. Sulat ko lang, tapos isa-isahin natin. We have y cosine z raised to 5 dx, dx dy dz. Okay, now, so i-check natin yung mga bounds natin sa region. Okay, since yung nasa loob na integral natin is with respect to x, so ang titignan nating bounds ay for the values of x. So as given, since it's bounded above the region and by this values, so si x is from 0 to 3. So we write here, okay, from 0 to 3. Okay, now for y, okay, sabi natin, for y, we have this equation, okay, in terms of z. So it is below this cylinder actually, y equals z squared. So ibig sabihin, nasa taas itong y equals z squared. Okay, and then sa baba niya, we have 0. Okay, so we have, yung bounds natin is from 0 to z squared. Okay, and also, so last one, for the value of z, so yung bounds natin for the value of z ay 0 to 1. Okay, so we write 0 to 1. So, pwede na natin siyang evaluate since kompleto na, nasulat na natin siya in its iterative form. Okay, so paano tayo mag-evaluate? So, similar with the double integral, unahin natin yung nasa loob. Okay, so we start with this. We evaluate this integral with respect to x. So, okay, sulat lang natin yung ibang hindi pa natin gagalawin. Integral z squared. And then, sige, evaluate na natin to. Okay, since we are evaluating the integral with respect to x, so yung mga terms na walang x, i-consider natin as constant. Since wala naman x dito, so this whole quantity is actually a constant lang. Hence, integral ng dx is just x. Sulat natin. Sulat natin si constant y cosine z raised to 5. Yung integral natin is just x. Okay, evaluated from 0 to 3. dy dz. Okay, and then simplify lang natin ito. So we will have from 0 to 1 z squared. Okay, we have substitute. So we will get 3y cosine z raised to 5. Okay, ito mag-0 lang. So mag-0 lang yung buong term kapag sinubstitute natin to. So wag na natin isulat. Okay, and then we have dy dz. Okay. Next. Okay, so tapos na tayo dun sa isa. Okay, sunod naman natin itong part na to. Okay, this inner integral will be evaluated with respect to y. So, i-consider lang natin dito or integrate natin ay ito. The rest will be constant. Okay, so we have from 0 to 1. Ay, yung isa lang. Iba natin to. Then, integral nito, we have, integral ng y, we have y squared. So, isa, lagay ko na dito, no? Wait lang. Dito. Lagay mo natin yung constants. We have 3 cosine z raised to 5. And then, integral ni y is y squared over to evaluate from 0 to z squared. Okay? Ang natira na lang ay si dz. Okay. Then further evaluate this. You'll get 0 to 1. So, magiging 3. Lagay ko na dito yung 1/2 kasama ng constant na numerical. And then, evaluating this, you'll get z raised to 4 cosine z raised to 5. And then, same thing, kapag substitute natin si 0 dito, magsi-0 out lang din. So, hindi na natin isusulat. Okay? And then, okay. Okay. So, dito, evaluate lang natin to. So, kung nalilito kayo, pwede natin ilabas sa integral yung constant. Okay, para ma-imagine lang natin kung ano yung gagawin natin dito. So, we have 3/2 from 0 to 1, z raised to 4, cosine z raised to 5, dz. Okay, so, gamit lang tayo dito ng chain rule on integration. Okay, we let u equals z raised to 5. We let u equals z raised to 5. Okay? And then, si du equals sa 5z raised to 4. Okay, take note here, kung ayaw nyo na siya i-revert back to z, okay, palitan din natin yung bounds. So, if z equals 1, so si u natin equals sa 1 din. And then, if z is equal to 0, then cu is also equal to 0. Okay, so same lang. So, walang problema. Okay, so we'll have 3/2 integral from 0 to 1. After changing the variable, okay, we will get, ay nakalimutan ko yung dz pala. Sorry. Huwag natin kalimutan yung dz dito. Okay, so we will have here, kailangan natin mag-add dito na, mag-multiply ng 5 dito. Pag nag-multiply ng 5, we have to divide by 5. So, i-multiply ko na lang dito. Times 1/5. Okay, so we will have, ay, burahin ko lang to. Computing na natin to. Oops. Ayaw. Small eraser. Burahin natin. Okay. Ayaw. Sorry. Ano to? Ayaw bumalik sa pen. Wait lang ah. Ayan. Okay. So we have 3/10. Aray. And then ito, after changing variable, we will have cosine u du. Okay, so madali na ito. Evaluate the integral, you'll get 3/10. The integral ng cosine u is sine u. Evaluate from 0 to 1. Okay, so evaluating this, you'll get 3/10 times sine 1 minus sine 0. Okay, yung sine 0 natin, this is just 0. So you'll have 3/10 sine 1. Okay, so ito po yung ating final answer. Okay? Question po? Medyo mahaba yung solution. Okay, so para lang formal. Lagay natin siya sa sa box. Okay? May question po? Ay, wala. So let's proceed to the second item. So, Okay, this is just evaluating triple integral. So, naka-iterative form na siya. Okay? Sige. Okay, ganun ulit yung gagawin dun sa item number 1. Okay, we start with the inner integral. So, we will have from 0 to 2 ng 0 to 2, 0 to y. And then evaluate this with respect to x. So ito lang yung ating, ito yung consider natin and the rest ay constant. Pero dahil nag-a-add tayo dito, okay, so ito, evaluate natin, we will have x squared over 2 minus, pwede na siguro natin ito pagsamahin, no? Okay, gawin natin siyang y minus z times x, okay, evaluated from 0 to y plus z. Okay, take note, nag-consider tayo ng constant dito. Okay, baka lang, hindi na natin siya pansinin. So, since constant siya at nag-a-add lang naman tayo dito, kailangan pa rin natin siyang evaluate yung integral with respect to x. So, constant siya, integral niya is this one times x. Then we have dz, dy. So, evaluating this further, we will have x squared. Substitute na pala, sorry. Okay, so we will have here y plus z squared over 2. Parang mahaba ito. Minus y minus z times y plus z. Okay. dz, dy. Okay, take note, hindi ko na sinubstitute to kasi mag-0 lang din naman. Okay. And then simplify lang natin. So we will have this is y squared plus 2yz plus z squared minus y squared plus z squared. Ito pala may over 2. Okay, dz, dy. Ay, mukhang mahaba pala yung solution dito. Ay, wait lang.
Pwede mo siguro pakita na lang yung final answer. Kasi ano naman siya,
Okay,
iterative
mahaba pala
naman.
to.
Yeah, iterative naman yung process.
Ay, wait lang. Okay, similar lang din naman yung process with item number 1, no? Nasa na yung solution. Okay, magiging final answer dapat dito ay positive 2. Very shortcut na yung ginawa eh. Wait lang, kunin lang. Sige, hindi ko na lang ipapakita yung yung buong process. Okay, dapat ang makuha nyo dito ay positive 2. Okay, so may value. Okay, so sa last integral naman, sa outer integral, you have to evaluate the variable y after integrating to 0 to 2. Okay, so magiging sagot mo lang dyan ay 2. Okay, kung mali ako, consult nyo. Kung mali yung nakuha nyo, consult nyo ako. Okay? So medyo mahaba pala ito. Okay, next one. Like for item number 3, so this is just the setting up triple integral. Okay, that will give us the volume for the region described by this. Actually, dito sa item na to may kulang ako. May kulang dito. This should be above. Okay, this solid. Okay, so given na tayo dito ng graph ng region natin. Okay, intersections lang ng mga to. So we have, for z equals 8 minus x squared minus y squared, we have this paraboloid. Ito. Okay, kita po ba natin? And also, we have this solid dun sa baba, which is the conic, half ng cone, ng cone pala, ng cone. Okay. And then for and a cylinder, so sa loob ng cylinder na x squared plus y squared equals 4. So yung ating region is actually ito. Okay? So itong part na to hanggang dito. Okay, na-imagine po. Okay, nasa baba ni cone. Ay, nasa baba. Ano ba? Sa taas ni cone, sa baba ni paraboloid, and then sa loob nung cylinder. Okay? So, yun po yung ating region. Okay, now, so the best, ano yun, pinakamadali na order of integration to consider here is, so yung nasa loob yung dz natin, okay, yung order of integration natin is we start with dz. Okay, and then, yung for the part of sa dA, so kahit anong form nito or kahit anong order ng x and y ay okay lang. Pero dito, mas maganda kung uunahin natin si dz since kita na natin agad yung boundaries niya. Okay? Nung value for z. Okay, so here, so knowing that, actually we can create here, sigurahin ko na ulit yung ano. Sigurahin na natin. Ito. Okay, then mag-create tayo ng rectangular prism. Okay, let's create a rectangular ang OC bag. Oops. Okay. So, create tayo ng rectangular prism dito. Okay. So, imagine na lang na rectangular prism yan. Okay. So, ito yung consider natin. And then, for the bounds of dz, ang gawin na natin ay dz, okay, dy, okay, dx. Okay. So, from here, so kita natin na yung rectangular prism natin dito is from here, mula dun sa cone, which is this one. Okay? And then, up to the paraboloid na z equals 8 minus x squared minus y squared. Okay? So, yung ating volume ay sa umpisa, o sa inner integral, we have from negative square root of 4x squared plus 4y squared up to 8 minus x squared minus y squared. Okay? Now, so yung for the area, i-graph na lang natin. Okay, sa loob lang siya nito. Okay, so circle lang naman yan with radius 2. Okay, so in this case, kung ito yung ating kasunod na variable for integration, so yung bounds natin should be in terms of x, and then gagamitin natin itong equation na to. So we write, kagaya ng ginawa ni Sir RD kanina, so we write this, yung y, in terms of the other variable. So we have y equals positive negative square root of 4 minus x squared. Okay, so dahil kukunin din natin yung, para hindi na tayo maghati-hati, no? So, dito, since we are using this, no? So, ito ay x, y. Okay, let us, we are actually using a vertical strip here. Okay? So, yung sa taas, okay, that's square, y equals, ano ba yan? Y equals positive square root of 4 minus x squared. Yung sa baba, you have y equals, itong part na to, is y equals negative, ano ba yan? Negative square root of 4 minus x squared. Okay? So, yung bounds natin for y ay ito lang. Okay? So, we have negative square root of 4 minus x squared up to square root of 4 minus x squared. Okay, and then lastly, okay, for the values of x, so mula lang siya dito Okay, negative 2 hanggang kay positive 2. Hence, yung bounds natin for this integral is negative 2 to positive 2. Okay? Nasundan po ba? Hello. Okay, so kung walang tanong, okay, proceed po tayo sa susunod. Okay, set up lang din ulit. And then, hindi ko nasagutan yung pag-solve ng... So, set up lang natin siya given this order of octant that is below 4x plus 8y plus z equals 16. Okay, yung ating given region is just similar dun sa example dun sa video. Okay, so you can just graph this. Makakatulong po yung pag-graph nung plane, nung plane, and then identify nyo yung solid na mapo-form. Okay, and then you can do the same process as in dun sa video. Okay? And then, dito sa last item, so medyo late na pala tayo. Ayaw mag-move. So, papakita ko na lang dito sa last item yung graph or yung solid na mapo-form. Okay, and then similarly, you can do yung process sa item number 3 dito. Okay, explain lang natin or imaginein lang natin kung ano yung solid and then how will you do it. Pero dito kasi naka-specify na kung ano yung order of integration na kailangan yung gamitin. Okay, so dito given ka lang ng yung bounds natin is the xy plane. So ito yung xy plane natin. This one, it's a red and green axis. So yan yung ating xy plane. And then, we have the plane z equals 2y. So, itong paslant na to. And then, we have the cylinder na parabola. Itong in red graph. So, yung region na tinutukoy natin dito ay ito. So, kita po ba natin to? Ayan. Okay, so yan po yung ating solid. Okay, and then kung with respect to z ito, so ang kailangan nyo lang gamitin ay, so you have this, and yung graph natin, yung equation for the xy plane is just z equals 0. Okay? And then, for the other bounds for integrals natin dito, okay, so ang gagamitin nyo lang ay meron kang parabola opening downward. Okay, so meron ka dyang 4. Okay, hanggang dito lamang. Okay, pa ganun. Okay, and then use horizontal strip. Okay. So use horizontal strip to get the bounds. Okay? So maybe that's it. Sige, pakita natin yung sagot. Okay, so we'll have volume. Okay, so lagay na tayo ng 3. And then d, z, d, x, d, y. So for dz, sabi natin we have 0 to 2y. For x, so we just write this one, okay, in terms of y. So that would be negative square root of 4 minus y to square root of 4 minus y. And then we have 0 to 4. Okay, so that's it for section 4.3. Do you have any questions po? Okay, yung tips lang dito, actually, dapat alam nyo yung itsura ng inyong solid. Okay, para mas madali nyong ma-identify yung bounds na gagamitin for integration. May question po?
Yeah, actually the takeaway point from here is that you should know how to sketch the solid. So if you have the order of integration dz, dx, dy, your first variable here is z. So that means ang i-consider mo ay yung buong solid. So yung expression mo for the bounds should be z in terms of x and y. Then yung next variable mo dito ay x. So that means you are considering the projection of the solid onto the xy plane. So yung mga variables mo dito ay in terms of x and y na lang. So dapat wala nang z na lalabas na sa expression. Ay, Ma'am Shi, tinaas mo, nawala yung annotation ko.
Ay, sorry.
Ikaw naman. So yung next variable mo dito,
Sorry.
dx. It's okay. Yung next variable mo dito ay dx. So dapat yung expression mo or bounds mo for x should be a function of y. And yung last variable mo dito ay y. So ang y mo ngayon, ang bounds mo dapat dyan ay constant. Yung smallest value for y and largest value for y. So that's how you should think of giving bounds to these variables. Again, kung dz, so ang functions mo ay in terms of x and y. Then yung next ay dx, so that will be a function of y. Then so dun sa dy, constants na yung mga bounds. Ayan, binura ko na yung annotation ko.
Ayan.
Okay, so do you have further questions, clarifications? Thank you, Ma'am Sheena.
Okay po. Kung nahirapan pa sila mag-graph, pwede silang gumamit ng GeoGebra online. So, para mas madali nilang ma-imagine yung solid.
Yeah,
Ayun lang,
they can use GeoGebra. They can also use Desmos
Yes.
for graphing 3D surfaces.
Ay, nakaka-stop share.
Okay, siguro wala naman silang mga questions. Baka natutulog na itong mga batang to. Anyway, pwede nyo namang
Sa YouTube, sir, baka may tanong ba?
Wala.
Nakakakaba. Charot, joke lang.
Buhay pa po, sir. Anyway, pwede nyo naman balikan yung yung video. So that's it for today. So we're done up to 4.3. So meron na lang tayong last. So meron na lang tayong last 3 sections for Math 28 Bridging Program. Konting-konti na lang matatapos yun na yung Bridging Program. Take note that you should answer all of the quizzes in the Bridge Program, okay, para makakuha kayo ng Certificate of Completion. Okay? So the last 3 topics are sections 4.4 to 4.6. 4.4 will cover change of integration. That is very important, especially if you will be solving double and triple integrals that at first glance, it is difficult to find an explicit solution for this. But the only way around is to change the order of integration so that you can solve analytically those multiple integrals. 4.5 is about multiple integrals in polar coordinates. So that will involve double and triple integrals in polar coordinates, because in the previous section, we only consider Cartesian coordinates. And the last section, actually ito yung pinaka-interesting na part, triple integrals in cylindrical and spherical coordinates. Because there are some expressions that if we convert to cylindrical and spherical coordinates, mas madaling hanapan ng integrals. Mas madaling mag-evaluate, mas madaling mag-express ng integrals. Alright? So I think that's it for today. So if you have some questions, send us an email, ask your learning mentor. And ayun, 3 sections na lang, matatapos na yung bridge program. And if you are done with all of the video lectures, the quizzes and exercises, hopefully hindi na kayo mahirapan with your succeeding courses. Okay? So kung wala na kayong questions, have a good day. Bye.
Salamat po, sir.
All right, you're welcome.
Thank you po, sir.
You're welcome.
Thank you, sir.
All right, see you next week.